This question is a combination question. Firstly, in part A, it is a graph sketching question. In fact, it's a reciprocal quadratic graph sketching question. And in part B, we find the exact area bounded by f of x, the x-axis, and the lines x is -3 and x is +3. So let's have a go at this and see what we can find out. In part A, alright, we have to sketch the graph of f of x. Firstly, f of x is 4 over x squared minus 16. I've divided top and bottom by 2 to make it easier before we even get started. Okay? Now, I've put it in that form, putting the denominator as a difference of 2 squares. So that's x minus 4, x plus 4, which we're going to need later on, and it helps us to understand what the graph's doing. Okay, now you can see that that's a reciprocal quadratic, can't you? Yes, definitely. The quadratic is x minus 4 times x plus 4. Now we better work out what our intercepts are now. So the y-intercept when x is 0, if you put x is 0 into this, guys, look, you're just going to get 4 over minus 16, or minus 4 over 16, which is minus a quarter. Yes, very good. Now that's the y-intercept. Now for an x-intercept, we're not going to get one, guys, because if you set y equal to 0, or up here, this equal to 0, that won't solve correctly. You're going to end up getting 4 equals 0, which makes no sense. So there's no x-intercept, all right? Now, asymptotes. You can see that if you have 0 on the denominator here, which would occur if this x minus 4 times x plus 4 was equal to 0, then x would be plus 4 or x would be minus 4. So x is plus 4 or minus 4 makes the denominator 0, which makes the function undefined, which makes for vertical asymptotes for the reciprocal quadratic. Alright? I think we're pretty well good to go now, guys. So let's have a go at this. There is the original denominator function. Okay, that's just y equals x squared minus 16, which I like to put in dotted form just to give myself a bit of insurance about getting the reciprocal quadratic correct, okay? Because you know, in that situation where the original denominator quadratic is positive, then the reciprocal will also be positive. When the original denominator quadratic is negative, so will the reciprocal be negative. And when the original denominator quadratic is 0, that's when that makes the actual reciprocal undefined. So that's that point, and that point there will be where your vertical asymptotes are. Exactly there, guys. Now, with that knowledge, we can put in our function f of x, 4 over x squared minus 16, and there it is, okay? So, it's just as we thought. We've got it positive here, we've got it positive over there, and as the original quadratic, denominator quadratic gets bigger, so does the reciprocal get smaller. It's undefined here at the vertical asymptotes, and we've got the situation over here where it zooms in here for a y-intercept of minus a quarter and then zooms back down again here. And as it gets larger and negative, the reciprocal gets smaller and negative. As it gets smaller and negative approaching 0, this reciprocal gets larger and negative approaching negative infinity. It all makes sense, doesn't it? Now, if we got everything labelled, let's have a look. We've got x is plus 4 vertical asymptote, x is minus 4 vertical asymptote. The other asymptote, of course, which you shouldn't forget, is the x-axis, because as x gets bigger, here f of x approaches and gets closer and closer and closer to 0, you see? So the x-axis, or y equals 0, is another asymptote. We've also got our y-intercept drawn in there, so I think everything's really good. We've got f of x labelled here, here, and down here. Yes, I think that's full marks for us, guys. Alright, now, what does part B require of us? We've got to find the exact area bounded by f of x, the x-axis and the lines. X is minus 3 and x is plus 3. Okay, well, let's have a look at that. X is minus 3 would be about here. X is plus 3 would be about here. The curve is here between those two vertical lines, and there's the x-axis. So okay, there's our region there. I'm just going around the boundary of it now, okay? Now, I think you can see that that will give us, if we're going from -3 to +3, that will give us a negative integral. And if we're looking for an area, guys, that can't be negative. So we would have to do the absolute value of the integral, or to make it positive, we could do the negative of that integral. That's very important. Please get that right, okay? Because they might just be setting you up for a fall if you don't notice that. Alright, so the area is the absolute value of the integral of f of x with respect to x, and don't forget the dx, by the way, from -3 to +3. Okay, now, here's a little trick for you. What I've done here is I've done the negative to take care of this making it positive problem we were anticipating. But what I've done is twice the, in fact, negative twice, that makes it positive, and the twice bit is because it's the actual area is symmetrical about the y-axis, as we noted on the previous page, then we can simply just integrate twice from 0 to 3, which is really always a really good idea, because if you're integrating with one of your terminals from 0, it just makes it a lot easier. Sometimes it just comes out completely as 0 for part of your evaluation there, if you're substituting 0 in for your x values. But in any event, it just makes it easier. So let's do it that way, can we? Right, let's go. Now, alright, well that's looking promising, except that we're going to have to put that 4 out there to get rid of it. Remember, you can put constants outside the integral sign because you don't have to evaluate constants, you don't have to integrate them. And then we're going to have to partial fractionate this beastly looking thing, alright? So let's go with that. Okay, that's good. Now, okay, here comes the partial fractions. Did you realise that's what you've got to do for anti-differentiating that? I hope so. So there it goes. So that's going to be a over the first term plus b over the second term. Now, multiplying right through by this denominator here, we get that. Okay. Now, instead of multiplying these brackets out and then collecting like terms and equating coefficients, look, you don't have to do that in a situation like this. What you do is you pick strategic values of x to make one of these terms 0. I'll show you. It's absolutely cool. So if x was -4, guys, then this equation would become 1 equals nothing minus 8b, right? Therefore b is -1/8. It just drops out like that. It's incredible. Now we're going to pick, for the next trick, we're going to pick x's plus 4, okay? And what happens then is this becomes 1 is equal to 8a plus nothing. So therefore a is 1 over 8. Yes, I know, it is very exciting. If you didn't know that, that's a terrific revelation to know how to do that. Alright, so let's keep going. Now, therefore we've got the area is equal to, now what I've done, guys, is the 1 over 8, this a term and this b term, I've taken it outside the integral sign to give us this, right? So we've got -1 now, and I'm integrating this thing here, alright? Both of those will be loggy terms, and don't forget the modulus, guys. There it is, okay? Minus modulus, wait a minute, minus log of modulus x minus 4 base e, minus log of modulus x plus 4 base e, integrated from 0 to 3, alright? So far so good. Now I think we'll just combine those terms to make it a bit easier using the log laws. So that's minus the log base e of the modulus of x minus 4 over x plus 4, and it's looking pretty cool. Now let's substitute our terminal values in now, guys, and we're nearly there. So it's going to be minus the log of, now if you substitute 3 in there, you'll get 3 minus 4, which is -1, over 3 plus 4, which is 7. So that's how you get that. Now, plus, remember there's a minus out here, so the first term will be minus, second term will be plus. So putting a 0 in here, we're going to get log of, right, -4 over plus 4, which is -1. Yes, everything's good. Now, let's just evaluate these modulus terms. The modulus of -1/7 is just 1/7, and the modulus of -1 is just 1. So let's dispense with the modulus signs now and just write it like that. Now you know, and I know, that equals 0. Of course it does. The log of 1, any base at all, is 0. Now, look at this little beast here. Without the minus sign out the front, this is the log of 1 minus the log of 7. The log of 1 is 0, so it just becomes minus the log of 7. So minus log 7 is plus log 7, and that's our answer. Yes, mighty cool. I hope you enjoyed it, and we'll see you next time. All the best.